Demo, horse survival. Problem statement. Predict the survival of a horse based on various observed medical conditions. Load the data from the horse.csv and check whether it contains any missing values. The dataset contains many categorical features. Replace them with label encoding. Replace the missing values with the most frequent value in each column. Fit a decision tree classifier and random forest classifier and observe the accuracy. You are supposed to fit a decision tree and compare its accuracy with random forest classifier. Let's import the required libraries. Import the data set horse.csv. The data set comprises of multiple features out of which we are trying to predict the values for the outcome variable. Let us now extract the values out of the outcome variable and store them in yet another variable named target for an easier understanding. Since we have already extracted the outcome variable as a target, we can go ahead and drop the outcome variable from the dataset. Now, since we are about to implement the decision tree model, we can recall that they don't work well with categorical variables. Let us store all the categorical variables within a list, namely surgery, age, temp underscore of underscore extremities, peripheral underscore pulse, mucus underscore membrane, capillary underscore refill underscore time, pain, peristalsis, abdominal underscore distension, nasogastric underscore tube, nasogastric underscore reflux, rectal underscore exam underscore feces, abdomen, abdomo underscore appearance, surgical underscore lesion, and CP underscore data. Now we convert the categorical variables into numeric ones using get underscore dummies parenthesis parenthesis method from pandas. Now import train test split and split the data into training and testing sets. We will import label encoder also, as it works fine with categorical variables and hence can be used to encode the categorical variables in the target data. Let's now extract the dependent and independent values as x and y. Initialize the label encoder. Use fit.transform function to fit transform target values. We have pre-processed our data for classification now. So let's go ahead and pull in the decision tree classifier from the sklearn.tree. Since we are dealing with decision trees, we must be very careful with the missing data points. The imputer with sklearn.preprocessing takes care of the same. The imputer with sklearn.preprocessing takes care of the same. Here we will be using the most frequent value to impute the missing values. Fit the imputer over the training data. Fit the imputer over the testing data. We are now good to go with fitting the decision tree classifier on our training data. Let's now do the predictions for our testing set. We will now use the accuracy score function within the sklearn.metrics library and check the accuracy of our model. We will now use the accuracy score function within the sklearn.metrics library and check the accuracy of our model. We can see that the accuracy came out to be 61%. Now, since we are practicing a modeling problem, it's always a better approach to try different models within the same vertical and search for better performance. Let's try out the random forest model, as from our learnings we know now that random forest is an ensemble of decision trees and hence most likely to give better accuracy. Fit this random forest classifier on the training data and use the predict function over the testing data. Check the accuracy. We may find the random forest classifier to be better than the decision tree in terms of accuracy. Now that we have compared both the classifiers, let's quickly recap the steps we have covered so far. Import libraries and the dataset. Pre-process the data using getDummies and label encoders. Impute the missing values using the most frequent values. Fit decision tree classifier on the transformed data. Print the accuracy. Fit random forest classifier on the transformed data. Print the accuracy of the random forest classifier model.